Science has profoundly altered the conditions of man's life, both materially and in ways of the spirit as well. It has extended the range of questions which man has a choice. It has extended man's freedom to make significant decisions. No one can predict what vast new continents of knowledge the future of science will discover.
We know that a scientist gains knowledge through observation of physical facts. He employs many devices, from the microscope to the atom smasher, to look at physical objects and events. He works with intricate measuring and counting devices. He makes use of any number of experimental techniques. But all of these are merely aids to observation. Most important of all, a scientist has to think about what he sees, to reason a problem through from observed facts to observable results.
We believe it's very realistic to expect that within the next 100 years, the amount of carbon dioxide naturally in the air will be doubled by all the fossil fuels that we will be burning in the meantime. A doubling of carbon dioxide may very well warm the Earth by something like 2 or 3 degrees Celsius.
Since the dawn of civilization, man, as all other creatures, has had to adapt to the changes in the climate and his environment that occurred naturally during the thousands of years that he was developing. But man, as usual, went one or more steps further than simple adaptation, and he has started to modify his environment.
Carbon dioxide is transparent to sunlight pouring down through the atmosphere to warm the Earth. But it is not transparent to heat radiation, which is welling back up from the Earth and trying to dissipate that heat into space. So it's like the glass in a greenhouse, where glass is also transparent to sunlight coming through, but it's opaque to heat radiation trying to escape back out of a greenhouse.
Solving such problems requires systematic observation and the gathering of many facts. All the factors bearing on the problem have to be investigated. Then, the facts have to be studied to find the best ways of solving the problem. And finally, the most promising solutions have to be tested in practice. This scientific method of thinking applies to any everyday problem which lends itself to observation and testing.
The satellite can provide you with measurements of global distribution of clouds, snow, and this radiation in, radiation out balance called the Earth Energy Balance.
But the search for more data on past climates continues. It has taken climatologists into the depths of the ancient forests in Arizona. There, in the cores of certain trees, they look for traces of rainfalls and temperatures from decades or even centuries long past. Tree rings are like diaries of climate cycles up to 3 centuries ago. Dry years of stunted growth, wetter years of rapid growth. These cycles of the past are clues to the future.
As the global temperature rises, it would shift the climatic belts on Earth. It would change the rainfall patterns. It would change again, it would influence again the crops.
To tell you what kind of water shortage situation we're getting into around here, we're now pumping from in excess of 200 feet. So we're starting to run out. And the only way this water gets replenished is by rain falling on the land. When you've got what amounts to 5 out of 6 years of constant drought, you're just taking out far more than ever finds its way back. There is no way in God's name that we can keep this up year after year after year.
Now, what kind of planet do you see?
One of two, depending on what happens by the year 2000. If by the year 2000 we have not solved the problems that face us today, then I would say 500 years we'll see a world containing a technological civilization in ruins, in which there will be a relatively small number of human beings sort of surviving, and with New York City as the most magnificent ruin in the history of the human race.